Hi, welcome. This video I am going to demonstrate how to start, get set up to do user-defined functions inside of MATLAB. Bear with me, I'm doing this unscripted, just pulling this out of my head as we go. So I'm going to start with the way that we used to have to do them back in the olden days, back in '02 or 3 years ago. Before things improved to where things are so much simpler now. So to do a user-defined function, the first word in your function must be the word function, followed by a space. The next item to be will be the variable that will be returned, or more commonly known as the return variable. The function will return to the main script file any value that is assigned to this variable. And this is a personal preference. It can be whatever you want. You could call this I don't care. You call it California if you want. I like descriptive variables, so result is the result from the function. And then the next thing that's going to be in there is the name of the function. Okay, this one is going to be called help me. And then inside of parentheses will be your input variable. So this is plain and simple. It's got one input and one output. I will show you how to handle multiple inputs and multiple outputs on the next function I demonstrate. And then you just come in here, and now it's just like you've been doing your homework. It's just a script file. This is going to be a stupid, simple function. I'm just going to say the result is equal to, and we'll take our input variable and raise it to the 5th power. Why the 5th power? Because it's there, and that's it. When you're doing a function, this method, that is all you need, is the function name, the return variable. So let me rephrase that. You need the name function, this blue one here, that tells MATLAB that this is a user-defined function. Then you need the return variable, the function name, and the input variables, and then do your function. Okay. Now, once you've done this, and you'll notice here that my current folder is empty. I've assigned it to my downloads location. When you hit save, MATLAB will automatically pull in the file name that you created in the function call, the help me. So that's all you have to do is hit save, and now you have a function. It's right there. There's the name of it. And when you go to the main script file, this is where you do all your homework. This is where you'll call up all the functions, do the whatever you need to do to it, and then create the tables or charts or plots or whatever the problem asks for. It's very simple now. We create a variable. Well, you don't have to create a variable, but I'm going to create a variable. I'm going to call it 3, and then I'm going to call my function. You just call it like you would any other function inside of MATLAB. So I give it the function name, the input variable that I'm sending to that function, fall inside of parentheses. And now when you execute that, it went into the function. It said x was equal to 3. It raised it to the 5th power and returned that result. Okay. But so you notice that this created a separate file. And now every time you write a new function, it will be a new M file. So we'll come over here, we'll create another function. This time we'll have 2 outputs. And I'm going to say, let's do one that raises 1 to the 6th power and 1 to the 7th power. So when you create multiple output variables, they go inside of square brackets. And this one's going to be called power me, and we'll still have one input. If you have multiple inputs, you just put them in here separated by commas. But I only want one. So this is how you would do multiple inputs, but we only want one, so we're going to go with the X. And so now we'll come down here and we'll say that 6th is going to equal x raised. We're going to make this to make sure that it's valid for vectors and matrices to the 6th power, and 7th is going to equal x dot raised to the 7th power. That's it. And then we save this again. We'll just hit the save button. It brings down the name of the function, and it saves it over here. Now we have PowerMe. Now this one, I know I've explained a lot on the max function. However, if you enter or save the output from the max function to 2 variables, the first will be the max, the second will be the location. The same will go for this. If you assign this to one single variable, okay, let's come down here and create a new cell, and let's go, there's an x in 6th is equal to PowerMe, and we'll go ahead and use that p value that we created up above. So now this will return one value, which will be 3. So yeah, if we multiplied that by 3, that would 6. Yeah, so that would be 729. So this is 3 raised to the 6th power. But if we go and assign the output to 2 variables, okay, I'm using the same variable names here. That doesn't have to be that way. You can use these separate. The variables in this function are local to this function. Once it's done with the function, they're gone. So now if we do our me and do p, you'll see here now we have the 6th and the 7th, and the 7th because I got this line up here, so I did the 6th twice. We got that 6th, and then the second 6th is from this one and the 7th. So if we want to see the output, we'll clear that and turn this one here to a comment, and now we'll see that you get 2 outputs. One of them is raised to the 6th power, and one is raised to the 7th power. So that's how you do multiple outputs, multiple inputs. Again, would just be a comma followed by all the variables that you're inputting. But you notice you're getting if you did this for back in the olden days, back when Moby Dick was a guppy, there was like 20-something different functions that each and every student had to submit one by one, and unless they zipped them into a file. And then I would have to sit there and manually download 26 of those from 50 or sometimes even 75 students. I was grading for 3 or 4 teachers, and that's a lot to do. However, MATLAB, or not MATLAB, MathWorks, the creators of MATLAB, finally got smart and made it a lot simpler. So let's say that we're going to do our homework up here, and we're going to just start out by saying that p is equal to 3, and we're going to say 6th is equal to, no, we'll use a different one. We'll capitalize it because that makes it different. PowerMe, and we'll send it to p, and we'll do also 7th is equal. But it's doing the same thing. No, this is a little bit different. Hang on, give me a second. I'm a slow one here. P. Okay, so here's our work that we're doing in the main script file, but instead of creating individual files, M files for each function, if you go to the very bottom of your M file and create a cell, and I like to label it down here as functions, and write your functions down here. And it's written the same way with one exception: function, and then we're going to have I'm just going to say results 1 and results 2 is equal to, and then power on me and a single input. Okay, the difference being here, again, you'll still assign the values to the output variable, and there's an R on the beginning of results. Results 1, come on, get up there, you can get there, you kumquat, is equal to x dot raised to the 6th, and results, I've got too many L's in there, get the L out of there. Okay, 2 is equal to x dot raised to the 7. Okay, here's the difference. When you're putting these functions at the end of your homework file, keeping them all in the same file, it must have an end. That defines that function. Now you can come down here and write in another function. Let's call this one answer 1 is equal to, let's do a square. And bring it in a value, and then answer 1 is equal to, no it's not, is equal to x dot raised to the 2. And you know, your functions can be as complex or as simple as they need to be. Also, one thing too, if you don't put the semicolon at the end of this, in fact, I'll leave it off on this one so you can see what happens. What it does is when it runs the function, it displays the results from the function in the command window, and then it goes back to your main script file and displays it again. So you'll get the results displayed twice. Okay, and then another end. So now we can come up here and do a squared, and we'll say t equals 9. And we'll do L equals, not minus equals, equals SQUAR of t. And so when we run this code here, we get those answers, and when we run this code down here, we get an error. Why do we get an error? Oh, because you got an R instead of an X. What an idiot. You didn't see that. So there we go. With one minor issue. So this works here, and it also works the same way inside of the live editor. If you go to the bottom of the live editor, put your functions in there, and make sure you end each function with an end. Okay, oh yes, so see here you got the answer 1 is this output, and then the L is this output up here. So by putting the semicolon back here, well, let's clear it off so you can see, not you. You can see here that it's the T, we don't want that output. That's not where we wanted the CLC either. You're an idiot. I don't know. That's what happens when you run unscripted. Sorry. Okay, so we'll run here. So see, you get the 2 answers, but if we come down and suppress that and run this again, now you only get the 1 from up here. Okay, short, sweet, simple. If you've got questions, by all means, send me an email, and if I don't know the answer, I will make it up. Thanks. Hi, it's me again. I just got done editing out all the boo-boos from the first part of that, and realized that there were a couple of items that I did not include in there. For one thing, if you're doing the old-fashioned method and creating an individual M file for each and every function, they must be in your current folder. If they're not in the current folder, you'll get an error saying that it's an undefined function. So make sure that you're saving all of your functions in the current folder.